Problem 848 is about a sample of 20 pages taken from a phone directory of 1,591 pages. It's about ads and how much area there is in the ad, and we're given 20. The sample is out of 20 ads that they measured. So, and they're asking us some questions here. So first thing is to notice over here is that over to the right there, we are measuring the area. And area is a continuous variable, hence we're dealing with the mean confidence interval, right? We're taking the mean of the data set that we have there. And because we do not know the population variance, we need to use the t-statistic, right? Now, if you use Excel for this data, you should be able to get the mean of 346.5. Remember, we use X bar because it's a sample mean. We use a standard deviation S because it's a sample also, and it comes to 170.398. Now, the formula that we need to use for a confidence interval is this one over here, right? And then the problem tells us that to construct a 95% confidence interval. So when we come here from the table, that means that we're using alpha equals 0.05. And to get our t-value, we need to calculate our degrees of freedom, and that's like a twisted v as in Victor, which is equal to n minus 1, in this case 20 minus 1, which is 19 degrees of freedom. And if you look at the table under alpha 0.05 with 19 degrees of freedom, you'll get a t of 2.093. Right? Now, all we need to do now is basically plug the number in to the formula, or the numbers, I'm sorry. And here it is, that's the mean, this is t, that's our s, and this is our n, which was equal to 20. Now, as you can see, all of the error times the t, which is this part right over here, equals 79.73. So our interval would be 346.5 plus or minus 79.73, which gives us an interval of 266.77 and 426.23. Now, second part of the problem basically asks us part B, I'm sorry, why might normality be an issue here? Well, because the data has 0. That's the answer right here. See the zeros right here? So if we have 0 there, right, and we have 0 here, we'll have 2 zeros right there, right, because the data has 0. We're going to have an issue if you do a frequency diagram, right, or a dot plot diagram. What's going to happen is that we're going to have values like this, and then all of a sudden we're going to have 0. We're all the way over here. So it's going to be skewed to the left, right? That's what's going to happen. All right. Now, part number C is just about, again, plugging numbers in the formula. And in chapter 8, there's a formula for finding out n, the sample size, which is this formula right here, which is equal to z times the standard deviation by the error. All of that squared, and we're given in the problem that they want an error of 10 millimeters right here. So it's a matter of plugging in the numbers again. For 95% confidence interval, z equals 2.577. That's for 95% confidence. All right. So we do the math. It comes out to 43.9. We square that, and it should be 1,927. And then the problem in part D basically asks us, well, that's a large sample. Could you suggest something else? Well, the only thing that I can think of is you need to increase the error. Well, we need to increase this number right here. So it's not 10. All right, so if the error, for example, would be 50, and we redo the calculation, we would get an n equal to 75. And that basically solves the problem for us. Thank you.